let me tell you just this right now. You're going to love this section. It's so much easier than circumcenters and orthocenters and all that sort of thing. This is going to be a breeze for you. I really like this section. It's a nice break from the complexity we've had in the last couple. Midsegments. A midsegment is a special segment of a triangle. A midsegment connects two midpoints. So every triangle has three midsegments. There'd be a third one here too. Okay? You don't want to, but that's where the midpoint is. They got the parallel line there thing. That's to help us understand what's going on. A midsegment has two special properties. It is parallel to a side, and it's always very obvious which side it's parallel to because it's a side it doesn't intersect. And it's exactly half the length of that side that it's parallel to. So parallel to and half the length. By the way, this makes a great new flashcard. Midsegment. Okay. Properties for the back. Parallel to a side. 1/2 length of that side. Pretty easy stuff. Easy to work with, easy to figure out. Midsegments are awesome. In the coordinate plane, very easy to work with. How do I find the midsegment? I find the midpoints of the two sides, I connect them. Okay? If it says show that it is that, I literally have to find the slopes of MN and JL, and I have to find the lengths of MN and JL. So we start using slope and distance formulas, but we aren't finding equations of lines or where they intersect, which is a lot easier. So I have to start by finding the coordinates of M and N. So M has coordinates, and really here I can read it off. It's at exactly -4, 3, because it's drawn in for me. N is clearly at 0, 2. So that certainly helps me. I'm also going to cheat a little bit finding the slopes. Slope of MN. Slope of MN is down 1 and right 1, 2, 3, 4. Slope of JL is down 2, right 1, 2, 3, 4, 5, 6, 7, 8. Which equals -1/4. I've just proven those are parallel. Finally, I have to find the length of MN. And if you've been paying attention to patterns, you may have noticed this by now. When I plug my numbers in, oops, I'm sorry, that's a minus inside. When I simplify these two values, what two numbers am I going to come up with? Guess what? -1 and 4, or 1 and -4, depending on how I put the order I put the numbers in. Watch it. So MN, M is at -4, 3, so -4, 3, N is at 0, 2. So -4 squared plus 1 squared. The 4 and the 1. Guess what happens when I square them? I get a 16 and a 1, or the square root of 17. Now, I'm not going to get a 1 and a 4 for JL because that's a reduced value. What numbers am I going to get? I'm going to get a 2 and an 8, aren't I? But let's prove it. So J is at -6, 1. L is at 2, -1. So -6 minus 2 is -8. Plus 2 squared. As I said, I get 8 and -2, or -8 and 2. When I square them, it doesn't matter which one was negative. That's 64 plus 4, or the square root of 68. Now you're saying, wait a minute, 68 isn't twice as much as 17. No, it isn't. It's how much more than 17? 4 times 17, or 2 root 17, exactly twice as long as mn. And literally that's the type of calculation you're going to wind up doing on the hardest problems in the coordinate plane here. Midpoint, slope, distance formulas. And sometimes we don't even need to use the formulas because we're given the picture. And it works out so nicely in the picture. Again, show the midsegment of DBE is parallel and that it's twice the length. That's exactly the calculations we just did. Now it says find the so I'm not going to worry about that right now. It says find the coordinates of the midpoint for segment EF, which is opposite AB. So I need to find the midpoint of this side, AC. Well, 1 plus 5 is 6. 6 divided by 2 is 3. And 3 negative 3 is going to be that midpoint. I'm going to call that point F. So we get inside my triangle another triangle. And that triangle is a dilation of the outer triangle. It's also reflected, or rotated 180 degrees if you want to look at it that way. So it's not congruent to the other triangle, but it is similar to the triangle because it's a dilation of the other triangle. The sides are all exactly half the length. The sides of the red triangle are all exactly half the length of the sides of the blue triangle, and the perimeter of the red triangle is half the perimeter of the blue triangle. So the midsegment triangle is interesting to us. It's exactly a 180 degree rotation and a dilation with a scale factor of 1/2. Taking it back to transformational terms. And we could prove all this using distance formula, using slope formula. I've done those for you so many times now, I don't think it's really necessary to continue to demonstrate those every time a problem comes up. I'm trusting at this point that you can handle those calculations. This one's interesting simply for the fact that it's proving our theorem for the general case using coordinate geometry. So instead of using normal proof, we're using coordinates to prove what's going on here. The points are given as 2Q and 2R for a reason, instead of just Q and R. And that reason is so when I find the midpoints, the midpoint for D here, 0 plus 2Q divided by that is just Q. And this is R. So that midpoint is QR. And this midpoint, 2Q plus 2P, is going to be Q plus P and R. All right? And what they want us to do is prove that they're parallel and prove that one is half the length of the other. So I would have to find the length and the slope of both of these. Now the slope is simple, because the slope is changing y over change in x. So r minus r for DE, slope, label what we're doing, r minus r over q minus q plus p. So that's 0 over negative p, which is 0. Guess what? The slope of OC is also clearly 0. It's a horizontal line. They're parallel. The length of OC, not too bad, because they only have one coordinate that's not a 0. It's 2p minus 0 squared plus 0 minus 0 squared, which is the square root of 2p squared, which is 2p. So now we need to find the length of DE, which would be the square root, and it's a little more complicated, but we can still do it. It's q plus p minus q squared plus r minus r squared. Well, q plus p minus q minus q cancels, leave me just p squared plus 0 squared or the square root of p squared, which is p. Guess what? P is exactly half of 2p. I've just proven that the midsegment is half the length of the side it's parallel to, and that they're parallel, both using coordinate geometry. Interesting stuff. But that's midsegments. I mean, they're not terribly difficult. A lot of the applications are a lot more practical. They don't involve any coordinate geometry. For example, here it says UV and VW are midsegments of triangle RST. So let's kind of highlight them. UV and VW are midsegments. We're told that VW is 57 inches. RT is 90 inches. They want us to find some other measurements. Okay? Namely, they want us to find UV, which is parallel to RT and half its length. So UV must be, very simply, half of 90 over 2, which is 45 inches. And RS is parallel to VW, but must be twice its length. So twice 57 is 104. And that's the length of our other side. Obviously useful if you're in the construction industry. You need to know how long to cut the beams for the roof trusses. All right, you're going to have a lot more problems like this than the coordinate ones in the homework, but you do have some work to work on, so I'll leave it at that point, and we'll see you in class.